Good morning or good afternoon, depending on where you are at. My name is Atarot Azizi Namini, Director of the IBT/ABC UTC at Florida International University. A very warm welcome to more than 1,130 sites that have registered to listen to our October 2025 monthly webinar live. We are delighted to bring another very interesting topic for you entitled Accelerated Bridge Construction in Texas through Research, Innovation, and Corporations. We are delighted to have with us Jamie Farris, Bridge Division Director with Texas DOT, and also Robert Owens, also with the Bridge Design Section with Texas DOT. During the registration process, we did receive a number of questions. We are going to try to get to them as time permitted, but it's not late. During the presentation, if you have some additional questions, please by all means post it on the dashboard and we'll try to get an answer to them. If we don't get the time to answer all the questions, we will provide the answer to all the questions we have received and post it on our website. So before we start the webinar, I just wanted to share with you a few important announcements. 2026 World Bridge Engineering Conference, before you know it, will be upon us. It's going to be held on December 1st and 2nd in Hyatt Regency Hotel in Miami, Florida. The conference is sponsored by U.S. Department of Transportation through their University Transportation Program and our Innovative Bridge Technology Accelerated Bridge Construction University Transportation Center here at the FIU. We truly appreciate the support of the U.S. Department of Transportation. We are also very thankful to the more than 32 state Department of Transportation who have co-sponsored the conference and will be helping us to develop the conference technical program. Just a couple of items. Deadline for submitting the online abstract is March 20. We would like to ask you, please don't wait until the deadline. If you have a good topics that is going to fit into the conference team, you can go to our website and view those. Please submit your abstract earlier. That will help us tremendously. There's also a cue card. The copy of all these PowerPoints will be posted on our website. We have reserved a block of room at a special conference rate. As you know, December, Miami, Florida is a very popular place. So we have reserved a block of room at a special conference rate. There is an opportunity to exhibit. Great opportunity because many state bridge engineers, bridge owners participate in this conference. There's also opportunity for state DOT bridge engineers and the county engineers and the bridge owners to apply for travel scholarship. We have a travel scholarship to assist you to come to the conference. There's an application form. It's not that much information really. You can get them. And then also more importantly, there's an award program. The deadline for submitting your application is June 30. There are many different categories for the award program, and I won't go through all of them, but you can visit our website and take a look at the categories that you can submit your nomination, and also deadline and what material do you need to submit. So with that, I'm going to turn it to Kathy Kroll to share with you some additional information about the upcoming bridge engineering events.
Thank you, Torad. My name is Kathy Kroll. I'm a co-director of technology transfer at the IBT/ABC UTC at Florida International University. Thank you all for joining us today for what is our 175th webinar in our monthly webinar series. And as Torad mentioned, we have over 1,100 attendees today, registered sites today. The IBT/ABC UTC is sponsored by the U.S. Department of Transportation through its University Transportation Program. We have gotten a number of questions from attendees on what exactly the UTC is, how it fits in with the US DOT. So the University Transportation Center program has been in existence since 1987 with a mandate to help address our nation's ever-growing need to maintain and enhance our transportation systems. The IBT/ABC UTC at Florida International University and our partner universities are focused on accelerated bridge construction and innovative bridge technologies. We'd like to express our appreciation to the US DOT and their UTC program for supporting the IBT ABC UTC so we can continue to serve the bridge engineering community with things like this webinar, as well as research and the conference. So before we get started with today's webinar, I'd like to share a few announcements. We'll start with upcoming events from our industry partners. The American Segmental Bridge Institute, ASBE, will be holding their 37th annual convention in Bellevue, Washington next week, October 27th through the 29th. See the link for additional information. I can't believe it's already time to start talking about events in 2026, but here we are. The first event of 2026 is the Transportation Research Board's 2026 annual meeting in Washington, D.C. from January 11th through the 15th. While I've not been to this event myself, I've been told by many that it is one of the most valuable of conferences. Registration is open. Another 2026 event that is on the horizon is the 2026 PCI convention at the Precast Show. It will be held February 2nd through the 6th in Kansas City, Missouri. Registration opens soon on November 13th. The next slide is our monthly industry news highlights. We've been sharing one interesting current piece of information from the bridge community each month. This month, we highlight the recently published NCHRP synthesis document on state DOT policies and practices on the use of corrosion-resistant reinforcing bars. This topic came up often in my DOT and consulting experience, often during value engineering discussions, but also as we were establishing standard practices. This document has great information to help direct these discussions, and it has really important information on life cycle cost analysis as well. The document is available for no cost in electronic format at the link below. Now for a few of our own IBT ABC UTC events. Our next quarterly research seminar will be held next week on October 31st, a Halloween event, from 1 to 2:15 Eastern. Our colleagues at University of Nevada, Reno will be presenting on data-driven computational framework for rapid post-event damage assessment of bridge infrastructure assets. Our next monthly webinar will be on Thursday, November 20th from 1 to 2:15 Eastern. The presentation will be a one-sided approach, the longitudinal launch of the Pretty Rocks Slide Bridge. This is a really amazing project. They longitudinally launched a 425-foot Warren truss over a landslide area to reopen about half of the main park road at Denali National Park. It's going to be really a great presentation. Devin Altman with Jacobs will be doing the introduction, and it'll be followed by Jason Sieg and Chris Sweetgall from KWH Constructors with the details. Registration is already open. You can sign up on the IBT ABC UTC website now. That's all for our announcements. On to our standard housekeeping items. As many of you know, these webinars are recorded and posted on the IBT ABC UTC website in the section titled Monthly Webinar Archives. So you can access this and all previous webinars for future learning and to share with interested colleagues. I'd also like to point out that a PDF version of today's presentation and these news slides is provided in the GoTo dashboard on the right side of your screen. You can download these PDFs during the training session. They will also be posted in the archives. I take that back, the news isn't posted in the website, but it will be posted in the archives. I do want to point out though that you can get the presentation for today in that handout section on this webinar. I point that out twice because sometimes we have a delay with so many people signed in, which is wonderful. But if you want, you can download that presentation and follow along at your own pace if you are experiencing a delay. So just know the presentation is available for download. Lastly, this presentation will be followed by approximately 15 minutes of question and answer. Please enter any questions you have in the question box in the GoTo dashboard. With that, we'll begin our feature presentation. I invite the presenters. We're happy to welcome Jamie Ferris and Robert Owens from the Texas Department of Transportation, who'll be telling you about how TxDOT is utilizing accelerated bridge construction and advancing the state of practice through research, innovation, and cooperation. Thank you both for sharing your time and expertise with us today. With that, we'll turn the screen controls over to the presenters.
All right, I will take it away. Like Kathy said, I'm Jamie Ferris. I'm the Director of TxDOT Bridge Division. And I just want to welcome you guys. Thank you for having me. And I'm just going to kind of do an introduction and give you a Texas welcome. This picture is of our Harbor Bridge in Corpus Christi. And it just recently opened, and we are very proud of it. And the picture is taken by Jason Pike from our design division. Just a little bit about Texas. As you know, we're known as the Lone Star State. I've got a picture that I took a couple years ago of some beautiful bluebonnets. We are the second largest state in the United States with over 260,000 square miles. We've got 254 counties, and we have over 29 million as of the 2020 census in population. Just a little bit about our bridges. We have over 56,000 bridges. For the on system, a little bit under 36,000, and then a little over 20,000 off system bridges. So we have quite a big inventory of bridges we take care of. And this just kind of gives you a snapshot of the states with the most bridges. And so as you can see, Texas, we almost double the next state with the most bridges. And this is looking at total count. And I also put the poor count, so that's the number of poor bridges. So we have quite a few, lower number of poor bridges compared to how many bridges we have, and we're pretty proud of that. And the next slide just kind of talks about, what have we been up to? This is not everything, but of course, just like a lot of states, we are focused on digital delivery. And working towards pilot projects, and we have a lot of different tools available to make that happen. We do monthly webinars. We call them bridge briefings, and so those are free. They're doing during lunchtime, and we started those about a year and a half ago. If you're needing just some example bridge items, we have over 875 bridge standards. And we also have bridge repair working drawings on our site that are, and all these are in PDF and DGN format. So you're able to do what you need to do with them, use them for whatever project you're working on. We also, we try to have data-driven decisions by using BRM and just, when we need to do certain treatments on our bridges for preventative maintenance. We have a full suite of dashboards that are for our districts to use and kind of see how they're doing for the different metrics that we follow. And like I said earlier, we try to focus on bridge preservation around the state. And over the last 3 years, we have increased significantly our in-house bridge maintenance. And we're doing that through training, getting out there and training the district workforce on how to do these repairs, and then also putting out a lot of tips for construction and repair. All right, so that's just a little snapshot, and I'll turn it over to you, Robert.
Thank you, Jamie. Welcome, everyone. My name is Robert Owens. I'm with the Bridge Design section of the Bridge Division of TxDOT. And so I'm going to kind of jump right into this. I have quite a few slides. I'm going to take you kind of down a path, starting with a little bit of history, within Texas, and it kind of leads you into like how we are evolving in terms of looking at ABC within the state of Texas. So I'll start here for table contents. I'm going to start off with the ABC the Texas way, what we've been doing and what's been working in terms of what we use in our standard details and how that has propelled us in terms of an ABC approach. And then I'm going to talk about a past project, just a sample project to kind of talk about, how we're, things we learn and how we're trying to evolve to improve our process and design decisions for ABC. And then I'm going to jump into, what we've learned, how it leads into new innovations, like allowing for alternates within plan sets, and then providing that those documents for our designers to make it easier as a toolkit for our designers to make these, more of a standard practice to also simplify also for our contractors. And then I'm going to jump into research and innovation at looking at, you know, what we've learned and again, expanding our options to even build faster. So I'll start off first with ABC the Texas way. Kind of a brief, just a little highlight here. You know, Texas, we're located, you know, centrally south located within the United States. So we have, you know, coastal regions, marine environment. We have, you know, desert regions, mountainous areas. We have the Panhandle of Texas, which can get quite cold. So we do have ice and snow. So we do have a varied, you know, temperature and, you know, geographic conditions within the state of Texas. Just a couple maps here to share. Looking at accelerated bridge construction. So I challenge people to rethink, you know, what accelerated bridge construction can be. So for you know, for TxDOT, we look at, you know, ABC is not just highly complex approaches. We look at, you know, what we have created within our standard library to actually help, you know, turn around these projects in a quick time frame. So that's our goal within TxDOT. So like a lot of our standards we use, you know, we prioritize, you know, prefabricated elements. Another thing that we do is we try to keep it simple. You know, this is feedback that we received from our contractors, you know, because they're the ones building these projects. So to keep it, you know, keep these projects moving quickly, I think keeping it simple is the key. You know, and again, we try to utilize many standard details and techniques as possible. And then I'll get into this a little bit later, but we also allow for opportunities to include multiple options within the plan set. So I'll kind of get into that more and how we kind of ended up with that as another tool in the toolbox. We accelerate. So, you know, for us, we try to precast as many elements as possible to speed up construction. So you kind of see several pictures here. You know, these are different things that we've used in past projects, you know, precast caps, abutments, and also precast columns. So, you know, Texas has a history of, I guess, in a way, we've been designing and detailing for ABC for a long time. You know, I guess one of the earliest inclinations for this approach is the use of our precast concrete deck panels, PCPs. You know, so, you know, we look at standardization. So we've created these standards and these details to accelerate construction. So you can kind of see, like at this picture on the top right, you know, it's an old picture. Yeah, so, you know, we've been using PCPs for a long time. And then so when we do that, when we standardize these details, it makes it, you know, a regular process and procedure for our contractors. And that's one of the benefits for standardization. And you can kind of see here too, we also, yeah, again, PCPs are panels, and then, you know, another go-to is our pre-stressed concrete beams. We have our Texas shapes that we developed back in the day. These have been around the early 2000s, mid 2000s. And again, you know, we work closely with our fabricators and to come up with these shapes and these designs to accelerate construction. And you can see that picture on the right. You can see the PCPs. You can kind of see how that comes together. So leading from the, you know, the Texas approach, like I said, we've always, you know, within our approach, we've standardized so many of our different elements that we've kind of created an ABC. Maybe it's not as fancy as some, you know, slide in and those types of projects, but, you know, standardization has really helped us. So then looking at a past project, we want to look at projects that we can learn from, right? Just also to innovate, to push the envelope and develop new procedures for our designers. So one project I'm gonna talk about is a project in the Bryan District. You can see the Bryan District here. It's located in East Central Texas. So this project actually was designed in conjunction with one of our consultant partners, one of our great partners that we work with in the consulting world. And this project covers Old Spanish Road within the district. You can see the bounds here within this project. It runs between these two stars. There were 5 bridge replacements on this route. One of them was over the Navasota River right here, a major river crossing. And you can see the detours on this route are pretty far. I think most of these detours are talking about 80+ miles to get from this location to this location. So we had to think of ways to accelerate construction. So again, rural highway with long detours. you know, it's definitely a good candidate. You can see the finished product here on the right. What we did on this project, we used milestone incentives to speed up construction. Within this project, the longer the multi-span bridges were completed in 22 to 20 days, typically, and those were 5-span bridges like over the Navasota River here, or you had some of the single-span bridges that we completed in 9 to 12 days. So this project, mobilization costs was about 4.3 million for these 5 bridge replacements. So, you know, maybe not the not the cheapest, but, you know, again, we wanted to get in here quickly to allow, you know, the traveling public to travel this route. And what we did is we looked at, you know, UHPC closure pours, but then we also developed our own in-house, what we called rapid set fiber reinforced concrete, you know, just due to the nature of UHPC and the proprietary, you know, costs associated with that. So we developed a Texas mix for UHPC. And construction access cost was also critical, you know, to fabricate and place these elements, and that costs about 800,000. So this, what we did on this project, or the consultant did, and then we worked with them, was developed a 6-girder system where they actually cast the deck with our Tex girder shapes off-site, and we created a, you know, prefabricated unit essentially with the deck and these girders. And what we did is we also you know, focused the closure pours within that rapid set fiber concrete over the top flanges to eliminate the need for forming. And we also did cast the rail with the exterior sections off-site. So, you know, one of the costs associated, like I mentioned, was the construction easement. So we needed to have a location to essentially construct these bridges due to the geometry controls, you know, to cast the decks on these girders, you know, off-site. So we're essentially constructing the bridge off-site in pieces per se, and then we actually place those pieces at the final location. So you can kind of see here, there's a couple pictures here showing the fabrication of the deck off-site. Again, you know, the geometry control is critical. So here, you know, this was, you know, setting the screeds to place the deck is critical. So you make sure you have that profile you're looking for. So when you actually place these elements at the final location, everything, you know, fits correctly. Here's a couple pictures. I showed these earlier. These were the precast concrete abutments that the contractor fabricated, and you can see those. You know, we actually had to change our standard details a little bit to get these, you know, to work. But you can see the final product there in place. And this picture shows the 2-girder system for one of the interior units. And this next picture shows the exterior element with the rail cast. And after you get all those pieces placed, then you come in with the UHPC closure pour, or rapid set fiber concrete pour, as we call it. And within these details, we stuck with the just more of the straight bar. Since we did have that engagement with that concrete, we were achieving around 16,000, 18,000 PSI. So, you know, we had, it was, you know, luckily that within that mix that we designed, you know, we were getting the strength that we needed for these connections. So what happened to, you know, from that project was we had a discussion with the contractor, so we could learn, you know, about how this process worked and what was, you know, what was working for them, what was not working for them. You know, again, to push innovation and to refine, you know, what we're doing in terms of designers to, you know, accelerate the construction. So again, the contractor mentioned, you know, considerations for site location, that's critical, access and shipping, you know, trying to ship those girders, especially in rural locations, you know, you might have smaller roadways, tighter, you know, turn radiuses. You know, you want to look at the risk and extra cost within building that mock-up. And again, you know, having to purchase or to provide construction easement, we did pay a cost premium of 40 to 15%. You know, the closure pours work well. Again, like I said, over the top flange as the form. And there were some complications within that UHPC mix because it was, you know, not as familiar, you know, the contractors are not as familiar with that type of mix. getting the fiber dosing correctly, the mixing equipment. But what you do is, you run through mock-ups to refine that and allow the contractor to be more familiar with within working with the UHPC mix. We were, extremely happy with the final product, and the contractor was actually generally receptive to this. They actually liked this process, and it did eliminate the need to phase these bridges with long construction durations. And the contractor did say it was a lot safer than a normal construction. So next, I'm going to jump into, looking at, like that past project, what can we do better? And one suggestion that was talked about, and leading up to, coming with our standardization of our elements, was looking at alternates allowed within our plan sets. So we look at, are there elements within your project that can be precast or prefabricated? It can also be a steel girder unit with a pre-top deck. It doesn't have to necessarily be a concrete superstructure. It could be a steel girder system, which we have used within projects within Texas. So again, legally we make sure we put these alternates within the plan sets as clearly stated, just due to legal requirements. Again, looking at the original design and construction ideas, then we can come up with new alternate plans. So the use of our alternates in terms of guidance is provided within our TxDOT Bridge Design Manual, our LRFD Design Manual. And within the manual, it clearly states, how to set these projects up, within the general note structure, of our plan set, and also to allow for, alternates for superstructure and substructure elements. And we do have an internal form that kind of documents this process, just to make sure, we check off the boxes, making sure that it's, clearly stated there's not going to be effects to time or schedule, or costs if there is an alternate that's proposed. And then again, this is something that we provide, allowance for post-letting. And these are applies to standard, bid and build projects. This does not apply to design build. So now I'm going to jump into our alternate standards within our package, and what we have available. So in terms of the tools that we've developed for designers, a lot of our standards can be found within our standards TxDOT standards website. You can use this link, and you can actually search, Google search TxDOT Bridge Division standards, and then you can click the link, and it'll kind of lead us to our vast library. Like Jamie said, we have 875 standards. And here's a snapshot, of a precast cap that we have, and we have, precast superstructure alternates and precast substructure alternates. So we did within those alternate standards, we called it a standard, but technically it's a working drawing per se. But what this does is it provides a roadmap for our designers to make sure that they're checking all the boxes, when it's going to go to letting. And so what we do is we've created these sheets where it has, the superstructure notes and or substructure notes, and the designer goes through them and, removes what doesn't apply to their project and retains that information that applies to their project. And for this, for us, we call it a standard, but like I said, it's more of a working drawing. And then there is this note to the designer that it's, it's a guide for preparing the plans. It's up to the engineer still to sign and seal these details, and they need to make sure that they're applicable to their design. And, again, the designer must read all the notes and remove what's not needed, and again, sign and seal. So, there is still, responsibility that the engineer needs to take when they use these details, but, it provides, like I said, a good roadmap, so they're not guessing. And these are based on what has worked in the past, and, and what we've refined over our various processes. So here's a link to our manual, our bridge design manual, that you can find here, and you can also Google search that too. And one thing we do stress is acceptance or denial of alternate is at the sole discretion of the DOT, and again impacts the schedule and cost, or the responsibility of the contractor. So that is the main disclaimer here. We're not going to pay extra for a different an alternate that's proposed. It needs to come at hopefully it would be at a cost savings to the contractor, and that would be the need to to push, innovation and allow these alternates. So, I do mention that we don't want to stifle innovation. So we do allow innovation, maybe to push the envelope, but for most of our projects, we try to keep it simple and more standard. Again, for the contractors, and we don't want to have, a research project per se when we're trying to make decisions, in terms of these alternates that will be used. And I'll kind of get into that later and how it kind of pushes into more of the innovation and research side, and where we can actually, test those new innovations and feel more confident about them. And here's a screenshot of some of the details for our precast standards. Like we have the precast, this is for substructure elements. We have the precast bend caps for concrete and steel piles, and then round columns, and the pre-stressed precast bend cap option. Another thing that we have been looking at, or we have pushed, is development of alternates for superstructure elements for concrete. We actually have what we call the wide flange Tex girders, and I'll get into that a little bit. And then we also allow alternate types of pre-stressed beams. I know in the past we have, with the past project with the Emila district, we did allow the use of the next beam, the northeast extreme T-beam. And for our continuous pre-stressed concrete splice girders, we have an allowance for alternates. Just due to the complexity of those structures, we want to make sure the contractor is able to make revisions to, in terms of means and methods, to offer that flexibility for them to speed up construction. Because contractors, have different means and methods, and they know best sometimes, and they can kind of work within parameters that we provide to them to accelerate the construction for splice girders. So again, the contractor has the option of furnishing either as designed pre-stressed beam girder or approved alternates when they're allowed. And all optional design submittals must be signed, sealed, and dated by professional engineer in Texas. And for splice girders, like I said, we try to allow for alternate designs, but we have working drawings that we have within those precast alternates that give parameters that are specific to splice girders. You have loading parameters that you need to look at, pre-tensioning and post-tensioning, and then those stress limits. So, these are the things that, if the contractor does want to have these redesigned or, come up with a new design for these are the parameters that we're looking for that forms the basis of that design. Because again, we don't want to change the design too much. So wide flange girders, I'm going to jump into this real quick. So here is the link here to wide flange girders within our standards library. And you can see on the picture on the left has the standard Tex girder shape, and then you have the wide flange girder. So the benefit to the wide flange girder is it provides a surface to eliminate the need to form the overhang. Because what we found is that the contractors, the less forming they have to do on site, the quicker they can accelerate construction. So typically we use the wide flange girders for exterior girder, and you can include 2 different span sheets, and here's a memo that a link here on how to use these. So here you see this typical section of what that would look like. And what we did too for designers to help them is we have updated our library within BridgeLink PG Super. TxDOT uses BridgeLink PG Super for beam design and analysis. So what we did is we created a library here for the different shapes. So we have the wide flange shapes here for what do we call our Texas 28 inch deep girders and 54s, 62s and 70s and 46s. So we create the toolbox here so that designers can jump right to it. And there's a typical section within that BridgeLink design software and what that looks like for an example. So now I'm going to jump into the research and innovation side. So looking at ways to accelerate construction with prefabricated elements. So the next thing that we're lucky enough within Texas to have a strong research program. And so you can actually see the link here to the CTR library. You can find a lot of our research that's within our research program. It's all documented. You can actually search, there's keyword searches you can make. and you can actually search specific projects using the project ID number. So the first one I'm going to talk about is developing and validation for precast column solutions for Texas bridges. And this was led by the University of Texas at Austin at CTR. So precast column history. So, again, we like innovation. We've tried different ways, to precast columns to accelerate construction. We've had, full height precast columns, which are extremely heavy, and you have to have a graded connection at the top and bottom. Those work well if you have the right equipment, and the contractor capability. But then we also look at other ways, is there a segmental approach maybe to, put these pieces together and maybe make them easier to handle and place. And then also, we looked at the shell option, which is lighter, and it provides, permanent formwork for the inside pour. And then we have the graded connection top and bottom. So we've gone through this history of precast columns. So what we were looking at was to focus on the shell approach because we wanted to, something light, easy to place for the contractor. So what we're looking at is, how does this perform or behave, and, are we going to feel confident that this is, a good method, as a designer? And so what we're looking at is, looking at the shear strength, bond between the precast shell and then the cast in place concrete. So what the University of Texas did is they set up, some full tests, full mock-up tests for these shells, and I'll kind of get into this here. So we looked at also different shapes. So we looked at, a square or rectangular footprint for the column and a circular. Circular interface, performed better, higher strength over that interface. And, one thing you might ask is like, well, if there's a difference in strength between the shell and the core, would that not perform as desired? But actually, what we found is it performed well, and there was no detrimental impact, within that difference. And then the other thing you want to look at is, is roughening the surface better, or can we just, fabricate these with more of a smooth surface to accelerate, fabrication? Because what we want to do is look at the process and how to fabricate these. We want to make it easier for the fabricator to want to do these. The less steps involved, the better for a fabricator. And, modest roughening of the surface did increase the interface strength by, almost 19–20% for the circular, average circular interfaces. But it didn't really have too much of effect. It was, we felt confident that if you didn't roughen the surface, it performed very well. So what the university did is that, again, they built up full-scale tests with the cap and then the connection into a footing. And that's a diagram there of that full-scale test mock-up. And then here is a couple shots of the shells. So these were actually spun cast in the fabrication yard. And you can see, again, we went through the process of intentionally roughening the interface and then not roughing it, just kind of leaving it as is. Some more pictures here. This would be the footing pictures here of the lab, placing the shell. Even just this shell section, they were, able to place it with just a, overhead current lift, and then with the help of a forklift to get that in place. More nice pictures from the lab there. You can see there the picture on the right is actually the CMP, the concrete metal pipe portion for the closure pour into the cap. So full-scale tests were done, low eccentricity at 6 and 12 inches, and the precast columns exhibited elastic behavior, indicating great, very good performance. So we were satisfied with that. Again, internal roughness of the precast columns had minimal impact on the final resistance, and the precast columns showed less cracking than the actual control specimen. And so there was a control specimen that was fabricated and load tested. And what's maybe not surprising, but the embedment length of the connecting bars significantly influenced the capacity of the precast columns. And so, you can dive into the research report. Like if you go to the CTR library at the beginning of that link, the hub link again, and you can type in this research report, so you can look at the report internally and read that. And the researchers provide us with some design assumptions, to help designers, suggested specifications and example details. So currently, right now, we're designing a AVC project for the Lubbock district using precast columns. So we're right now at the implementation phase. So we're going to put these to a real-world application. But I feel pretty confident that these are going to work very well. So that was an example of substructure. Now this is an advanced example for superstructure research that we have done. Again, with the CTR, there's the link there within the library, and there's a project number you can search. And so this was the development of next-gen Texas bridge decks. Again, we're trying to speed up construction on that bridge deck, make it safe for the contractor, and this was an idea that was developed. So this idea actually came from us from looking at projects overseas, and Spain. They use something very similar to what we researched within our project. So, again, you look at what other people are doing and get ideas from that to kind of help drive your innovation, and you push the envelope with each step, to accelerate construction and look at new details. So again, contractors, one of the things that they commented on, again, with the use of the wide flange girders and our normal, and our normal text girders, they want to eliminate the overhang in that forming and the time it takes to form. And so what we did is we looked at using a precast panel that's a wire truss partial depth panel that are fabricated to have two panels, one with the deck overhang and the one is the interior deck support. So you see what that looks like here. And you can see that wire truss system. It's actually a welded truss system. And then what we do is we actually go back with a, again, like a partial depth pour at this, within this section. Okay, you'll kind of see that here in the next couple of pictures. So here you see a little bit more detail of the actual PCP main panel, and here's the overhang. You can kind of see how this is formed up, and then what you do is you place these panels and then you come in with your cast in place concrete pour. Here's some pictures. So what the researchers did is, again, they built some full-scale mock-ups to look at the performance of these. There you can see the lateral, the forming of these panels in the lab, and here we just use like a foam and tape, a system when we place these panels to form them. And here's the specimen. So what we did is we looked at single panel tests here. We tested for a maximum moment and the maximum shear. And you can see the test setups there, those typical sections for those test setups. And you can see that picture there with the full scale test setup. And here's the single panel test. You can see these were, per flexure and shear. And you can see those are deflecting quite a bit. So here's the little isometric view here of the test setup. So what we also did is we looked at the process again, and we looked at fabrication, right? How can we make these easy to fabricate? So what we did is we looked at electro-welded wire trusses and then hand-welded wire trusses. Obviously electro-welded it's a little bit quicker, kind of automate the process. But then we also looked at hand-welded to allow fabricators that might not have that equipment to fabricate these, and give them a chance to and see how those perform, in terms of the different processes in fabricating these panels. And here's some pictures of the panels. And so what we did also too, that was the single panel test before. So now we also tested these within our text girders, constructing the bridge itself. So that was that isometric that we saw. And now here's the real world application. Some more pictures there. So again, they placed the panels here, and then they came back in and then poured the concrete, the cast in place portion. So you see the finished product right there. And so there was a punch and shear failure. You can see that this picture. So this is the side picture of the punch and shear failure from the side, and then from the bottom, and then from the top, and then here's the close-up. You can see there. So from that research, what we found, again, the researchers provide us with some design assumptions and specifications and examples. And you know, we found that these performed extremely well, and we feel very optimistic about using these for Texas bridge projects. And so we're now, you know, looking at implementation projects to implement these and use these. You know, and any of the goal for us within TxDOT is to use a lot of these, you know, standard details to speed and accelerate construction, and you know, make this a habit within our contractor, you know, for our contractors, and they get familiar with these, and you know, then our standard details just become ABC, and it's just, you know, ingrained into what the designers are doing, and then what the contractors are building. And you know, that's the way that we try to focus our, you know, our innovation towards ABC. And that concludes the presentation. And from what I understand, I think we're going to jump to the questions.
Yep. Thanks for a great presentation. Actually, lots of very informative points that you made. At this point, we're going to turn it to Paul Lyles to moderate the question and answer period.
Okay, thank you, Tori. We do have some questions. We have some that came in beforehand, and then some that have come in during the question during your presentation. So we'll jump into them. First question I have here, and this came in beforehand: how can accelerated bridge construction (ABC) methods be leveraged to enhance long-term structural performance and resistance?
Okay, so
resilience.
Okay, yeah. So again, like what we try to do with you know, for Texas is that we like to create, you know, tried and true details and standards to make it, you know, resilient, you know, in terms of, you know, making it easier for the contractor to build. You know, if you make it complicated, difficult, or if they're not familiar with something, I think that's where, you know, as designers, we can put this on paper, but you know, the contractors are gonna have to execute these. And what we find is that we get resiliency from, you know, standardizing these details, and that's just, you know, the history that we have. Again, you know, you do have to look at, you know, different environments, right? So, you know, if you're using a lot of de-ice and salts, you know, we do have allowances. You know, we use certain, you know, rebar, you know, galvanized rebar, you know, epoxy coated rebar. We still use epoxy coated rebar in Texas, but so we do look at those, you know, decisions. You know, again, also using UHPC or UHPC like mix for our connections. You know, that it's pretty durable. We test those in-house. We just develop specifications in-house that we test. So again, I think it's you know, testing, becoming familiar with these details, and you know, I think, you know, we see good history with performance.
Okay. Then how do you determine the design service life of your precast connection elements?
So connection elements, design service life, I know, you know, you can kind of get into the weeds, you know, looking at, you know, crunching numbers to get that design service life. Again, I think for us, we don't sit there and like crunch the numbers per se to figure out design service life. But like, again, it's more of like tried and true details, and then pushing the envelope with innovation and, you know, testing and research that we can feel comfortable that we're going to have the life and durability within our structures. And I think a lot of the history proves, at least within Texas, you know, Jamie showed that slide, you know, the condition poor bridges that we have in the state is extremely low considered to the volume of bridges that we have. So again, it's just something that's tried and true with what we do. And so we're not here crunching numbers, but we feel pretty confident we're getting what the life that we need out of these structures.
Okay. Misaligned precast elements can be issues in ABC. How can we eliminate such issues on site?
So, you know, like the Bryan District project that I was talking about, you know, where we learned from, it was, you know, extremely costly. You know, again, like I said, you're almost building the bridge, you know, off-site. Geometry controls are critical, and I think that was something that needs to be conveyed to not only the contractor but the fabricators you work with. So luckily have good working relationships with our fabricators. That's critical. I think communication is critical when you're fabricating these. I know we've had issues with, pieces being misaligned. Maybe fabricator misinterpreted the shop plans or something. So yeah, I get that it's important. Again, I think standardizing the details also, again, helps that, familiarity. If you're familiar with something, then you're not gonna make as many mistakes, right? And I think that's the goal, making it easy to construct and build and familiarity.
Okay. This question came in beforehand. It says, can you offer an opinion on cast in place concrete pour strips performance between full depth concrete panels on ABC project?
Okay. So, like I said, within Texas, we've used PCPs or precast panels for a long time. So it's a partial depth pour. And, when it's executed correctly, then we have good durability and long-term performance. And so there's no question about that. In terms of like the full depth options, we've gotten good, so far performance and durability out of those two. So, looking at those connections, stressing the importance of using like a UHPC or a fiber mix within those connections. But fabrication, on the fabrication side, you have a little bit more control, and that is the good thing, in terms of looking at the full depth panels and fabricating these offsite. You have a little bit more control, and also too, they can take the time to do things right. We have inspectors on site. So, I think performance-wise, we're seeing, very good performance for our full depth concrete decks and also our partial pour decks. So kind of equivalent so far from what I can tell.
Okay, this next one came in beforehand, but are you utilizing ultra high performance concrete in your ABC strategy? I know you covered it on the closure pours. Are you using it anywhere else at all?
No, not currently. I know we did have a research project that we led in Texas Research for, full scale UHPC girders, concrete girders. But we haven't really utilized those because we do get good durability within our concrete girders, that we have. There are some issues, at joints and stuff, on long term, areas where you use de-icing salts, but typically right now we've used it in closure pours, and we have used UHPC on repair projects, repairing girder ends. Actually, in Houston district, they did a project where they actually encased steel girders with UHPC because they were getting a significant amount of corrosion. So that was Tom Fan over Houston district. He utilized that UHPC on that project, and in-house too, we did a UHPC similar type of treatment for concrete historic bridge in the San Angelo district. It was a historic structure and arch structure that we strengthened the ends units because we were seeing it was built in the 1920s, but we were seeing some, concrete degradation. It was almost 100 years old, but we actually strengthened the ends of that structure with UHPC. But so far right now with our new structures, it's mostly closure pours.
Okay. What is TxDOT's stance regarding the use of proprietary and patented products, particularly when it comes to ABC?
So, so for us within Texas, legally, we can't specify specific proprietary products unless we have, different options. So that's what we do, like I said, within our standard library. That's why we try to innovate and design and lead that effort in-house. So it's not a specific proprietary product per se. So I think that's where we kind of maybe avoid that complication, because I know within Texas, legally we can't specify like a specific proprietary product. I know joints and stuff, we do have those in our standards, but we have, a collection of different types of joints and fabricators that we can use. But for us, like for these prefabricated units, we try to develop these in-house within our research program. Also working though too with our fabricators, but I think the goal is that our fabricators know that when we develop these, it provides them more revenue in terms of business, right? So I think having that close working relationship to the fabricators, they're open to new ideas, because the more they can fabricate and or save money and the contractor side in terms of time, then they're happy.
Okay, I'm going to skip to some questions that have come in during the presentation.
Okay.
In the bar chart in the opening slides where you show the total number of bridges per state, what do you consider poor bridges in the inventory?
So maybe, I don't know if Jamie's still on there, if she could speak up on that, but I've been kind of out of that world for a long time. But yeah, it would apply to the NBIS, the current NBIS. It'd be the same definition.
I think it used to be structurally deficient, and they're going to poor.
Yeah, back in the day, it used to be structurally
Yeah.
deficient, correct? Yeah, and then
Okay.
also functionally obsolete and all those old categories. But we
Yeah.
have all the new categories now.
Okay, here's a good one. Can anyone attend the Texas monthly webinar?
Yes, you can. So it's open to our consultants and in-house, TxDOT, and it's open to anyone nationwide. And they are very short in duration. They're only 30 minutes typically. We try to keep them short so that they don't eat up too much time for people. But it's a monthly webinar, and you can actually Google search that TxDOT Bridge Briefings, and you'll find the link to that. You can subscribe and join us for those. We cover a variety of topics, design, construction, geotechnical, inspection, a wide array of topics, and we're also open to ideas. So if you want us to, if you have ideas and what you want to see, we're also open to that too. But it is available to everyone.
Questions? Anyway, let's see. Is seismic design considered in Texas bridges?
Thankfully, it is not. So our seismic zones are pretty low. There are some seismic areas within Texas, but they're extremely low. So we're lucky, I guess, in that respect. So a lot of our details and obviously our connections, they're not they're not seismic connections per se. So and other states, it had to be find other ways to adapt them. But the short answer is no.
Okay, and then another wrinkle on that. Someone said even remote earthquakes can affect Texas bridges due to shale fracturing. How will the precast columns perform, especially in the Fort Worth area?
So what I can see, and based on what the research led us to find, I don't see an issue in terms of our column design. They're performed essentially the same as our standard cast in place column. So I don't really see a huge effect in terms of the seismic, and the seismic demand that we see, and like I said, within Texas, I understand the shale and the fracking does sometimes maybe possibly create local seismic zones, but based on the research, I don't think we're going to see any performance issues with the precast columns moving forward.
Okay. For redecking projects, what are the ABC options in Texas?
Oh, redecking. So what we try to do for redecking projects is we look at those decisions, starting from, does it need to be a full redecking? Thankfully, a lot of areas in Texas, we can get by with not having a full redecking project. Again, you got to do the investigation to look at the scope of damage, and also the age of the structure and those sorts of factors. But so we try to tend to steer away from them to the interruption to traffic. We don't really have specific, tools that we use to accelerate construction for redecking. I think again, we just try to look at, the least amount of pain that we can inflict on the project in terms of causing disruptions to the traveling public. So we try to look at maybe different types of overlay, maybe like a concrete structural overlay instead, or multiple polymer overlays, and look at those options instead of a full redecking. That's what we try to do.
Okay, we had one here. It says for the deck overhang and the barrier, are the deck overhang and the barrier walls precast? if they were, how were the segments temporarily supported? This question came in before you showed us the detail of the cross section with the parapet or the barrier thing on it.
So
but
yeah.
Yeah, go on.
Oh, I'm sorry. So yeah, that was actually, so what they did, you know, when they fabricated, like for example, in that Bryan project, they fabricated the bridge right offsite and without the closure pores. But so they fabricated the rail and the everything offsite. So and then as part of that unit, it was, you know, then placed. So it kind of, again, constructed the bridge offsite and then placed it in pieces at the location.
Okay, and for the wide flange beams designed to support the overhang, do you include loads for the deck finishing machine? And then how does the contractor typically place the concrete when the wide flange beams are used in practice?
So if I can go back, let me go back really quick if I can find it. But here, so this is basically, you know, the top flange here that's creates that overhang for the contractor. So there is actually, you know, a cast in place pour that happens. So again, like these are designed, like when we go into the designer, when they design the bridge, again, they go into PG Super BridgeLink and, you know, they pull up the library, they design the structure. And so that's all, you know, carried through the design. So it's a little deceiving because like you see the wide flange here and you see the deck on top. So this portion is actually the cast in place portion. There is like a curb element that's included that it's not really depicted, you know, 100% accurately, maybe in this picture, but it is included, you know, the design for the construction phase for the design of the girder.
Okay, now if the girder, if you're on a curved bridge, what do you do then? You had to form it traditionally?
So yeah, so curved structure is a little bit different. I guess that's the caveat. I guess maybe obvious to me, but I didn't clarify. Is that these are, you know, these work on like a tangent or straight curves. You know, if you have tangent, you can possibly chord these. That has been done, but yeah, on a curved structure, these would be a little difficult to execute. Yeah, you would have to go more to traditional method to forming the overhang and, you know, placing. So that is a little bit different. Geometry, you know, that controls, you know, that controls other things. So yeah, if you have that situation, these would be not the right tool.
Okay, we're running out of time. I'm going to turn it over to Rick, and he's going to come on and ask you a few questions before we end up.
Okay.
Really good. Thank you.
Sure. Thank you.
Hi, Robert. So
Hi.
A couple questions here, hit on real quick. The shear interface strength achieved after roughening on the surface between the shell and the CIP core, how was that? I'm assuming that was with the precast columns that you tested. And one of the questions I had, well, in the picture you showed, was that achieved with a spun concrete precasting? Is that the machine that you had shown? Okay.
Yeah, so that was the spun cast. It's a shell and it's spun cast fabrication. You all can see the picture here. So these are the shells here. So these were spun cast.
So the roughened surface there, did that achieve the strength, the shear strength between the two surfaces that you guys had expected to see?
Yes, it did increase the performance of these, the elastic, you know, behavior of that bond, you know, within that shell and then the cast in place core. But we didn't really see like a significant, you know, disadvantage to not roughening the surface. So they both performed extremely well. So, you know, again, if we simplify the process for the fabricator and stick with the smoother surface and eliminate that extra step, perfectly fine.
Good. Okay. Yeah. Anything you do to expedite things, right? So
yes, and save time and money.
So with the push to digital delivery, have the capabilities of OBM been utilized in current, or are you looking ahead at other ABC projects with the digital model?
Yes. So actually, currently the Lubbock project that we're working on, you know, we have 3D models. I don't know if that's going to be a full digital delivery project, but we do have models. That's our policy right now. We're building the models within TxDOT for each project. So one thing that's to note also is if you do go to our TxDOT Bridge Standards webpage, we actually have for each standard bridge, we actually have a model that's already created for the designer. So the designer can actually download that model and then use it for their project. So it's again, another way to help designers, simplify stuff for them, and get them familiar and then working within those models to hopefully use those in the future.
Yeah, good. Question here is interesting with the precast deck panels. In some states, they've shown longitudinal cracks on the top of the deck in multiple bridges. Have you seen any of this during either your testing or field observations?
So, we've used these for a long period of time, and we do see those occasionally. What we find is it's more of a constructability issue, right? So the contractors, you got to look at the roughness surface of the panel. Within our standard, we have roughness requirements. The other thing you need to look at is, looking at SSD condition, saturated surface dry condition of the panel, to help develop that bond. And I think that's typically what we see within that longitudinal crack that's propagated up from the panel corner edges to the deck surface. Again, making sure you get that bond. So a lot of it's about the contractor, again, familiarity and doing it the right way, right? So inspection controls are critical.
Sure. One quick last question here that kind of ties to that. How many bridges have you guys built to date with the full depth precast panels? And you can speculate, you don't have to have an exact number. So.
Yeah, so that's a little tough one. So the full depth ones, I mean, off the top of my head, I'm aware of maybe like 4 or 5, but there's probably more, but that would be the number off the top of my head.
Okay. So your standards, Robert, kind of do your standards account for skew? And then you did mention curve a little bit ago with Paul, I guess, and I know that throws some different geometrics into it, but
yes.
How do you address that with your standards that you guys have out there?
So our typical bridge standards, they're on straight bridges, but we do have skews up to 15, 30, 45 degree skew. So anything beyond the curved structure, horizontal curves, skews that fall in between those limits, then it's not standard. But what we try to do is, our roadway designers, luckily within Texas, they understand that. So then to simplify the process, to get these built quickly and designed easier, is they try to simplify the geometry to use our standards. Obviously it doesn't apply to every scenario. We have a lot of projects within Texas, but the standards, pull the largest weight of the projects that we have out there, so that geometry again will control the use of standards.
Have you, I guess, has Texas considered exploring or looking at 3D printed concrete for any of the ABC projects?
No, I guess short answer is no. I think it's maybe even talked about, but it has not been looked at for 3D printed concrete.
Yeah. Well, it's one of those things. It's out there, and it's going to be interesting to see. So, is the cost of ABC for the whole construction is usually considered about 40% more than conventional method in a lot of areas? Is that what you're seeing or not?
So if you talk about like our more I guess innovative or kind of fancy ABC projects, yes.
Sure.
But like again, what we call our standard details, what we also is an ABC in a way that we're finding out, where our costs are really excellent within Texas. So it depends on the complication, right? Again, increased complexity, more costs, but we do work with our contractors and our fabricators to look at those and find ways. But for us, especially in our urban environments within Texas, that we have large population, the traffic control costs, the phasing costs we find are exceeding those premiums.
Yeah, the MOT stuff. So
yes.
Yeah. So steel beam type construction, I mean, obviously you hit on concrete all the way through this, but I'm assuming the standards hit on using steel beams as well as the concrete beams on the ABC side.
So we have steel roll beam standard details. So we actually we've used steel superstructure full depth concrete units on a few projects. So one was the Dallas 635 Seagoville project. They actually they use steel girders there with full depth concrete, and essentially the same as that Bryan project with steel girders. So we also do allow, if we're looking at more allowances for like steel alternates for also precast concrete to allow the contractor that flexibility also. Especially when you're looking at stuff like splice girders, maybe steel might be a better option than concrete splice girders. So right now, case by case basis is critical on the use of steel. We love steel, so yeah, I know this is very concrete heavy, but we also love steel, and we use a lot of steel in Texas. I think a lot of people think we only just use concrete, but we do use a lot of steel. We also are using, within Texas, we're seeing a lot of the use of the triple steel caps, the I-girder section caps. That I think Connecticut was one of the first states that used that, and so we've taken those details and utilized those within Texas. Consultants have designed those, so that's another way of ABC, right? Instead of a concrete cap, you use a steel cap.
Okay.
So we do love steel too. So
okay, well, thanks, Robert. I think everything looked great, and I guess I'll turn it over to.
Thank you, Robert and Jamie. Very extremely good presentation. A very good example of how innovation finds its way into the practice when the state DOT work cooperatively with their university in their states. Again, please, if you have good projects that you think that you would like to share with the rest of your colleagues, deadline for the submitting an abstract is March 20. Please submit the abstract as early as possible. Don't wait until the last minute. That helps us tremendously. More importantly, mark your calendar and plan to attend the conference. Conference is going to include the award program. So if you go to our website, you will see all the categories and more information about the conference and what it comes with it. So on that note, we'll conclude our program, our webinar today, and hope to have you with us with our next event. Thank you.